Hello there, teachers and assessment enthusiasts. I'm Andrew. I'm an IB math tutor who has a passion for exam writing. So every exam season, May and November, I write mock IB exams for all IB students to attempt prior to the actual examinations for the last 5 years. So since May 2020. So we just celebrated our 10th mock anniversary. I've written hundreds of tests in various forms for different purposes, varied from unit tests to booster papers to mock exams. They all have different designs as they are for different purposes. And of course, comments and suggestions are always welcome. Now, today I would like to share about how I write mock exams. This is a long tutorial, so buckle up. I divided it into several parts. In case you're not aware, IB and various exam boards usually take a year and a half between the start of the program creation to the time when the papers are sitting in front of the students. I'm making a lot of simplifications to make the process less intimidating for me and hopefully teachers and perhaps heads of departments can consider using my process to create high quality mocks to obtain reliable and valid data for any intended use. Everything to know for each video will be linked in the description box. There's going to be a link to the spreadsheet that I use, and I will share this, or links to research papers that are relevant to the subject that we are discussing. So, the structure of the series. First off, we'll start with an overview of the exam writing process. Then we'll talk about the purposes of a mock exam. Next up, we'll discuss how to select topics for questions, as well as the actual writing. And before the papers are ready to go, let's talk about presentation, proofreading, and signing off. Let's start off with an overview of the mock exam. It is important to identify the purposes of the mock exam before the writing process commences, as it will dictate the level of detail in the procedure. Now, in my opinion, mock exams have several purposes, including but not limited to: 1. Deciding the most appropriate predicted grades for university. So this is more of a summative use. And this, in my opinion, is the most important goal. We'll talk more about it later. Secondly, is to inform students, teachers, and head departments the topics the students struggle with. This is more on the formative side, as we will use this data to inform our future teaching. And last but not least, it helps to familiarize students with the format, as well as time management techniques for them to show off what they have learned to the best of their ability. The most important goal, in my opinion, is to determine the most appropriate predicted grade, as students do really need this to go to university later on, especially if they are taking A levels. In essence, we are establishing a common meaning, aka this is standard of work that we expect from an A student on the actual exams. Therefore, this is N, this and their perform, and this is the corresponding performance on a mock exam that is kind of similar to the real exams. For those interested, I invite you to read Making Good Progress by Chris Dulu. This is a very good book as an introduction to assessment in general, as well as a paper from Dan William, Integrating Summative and Formative Functions of Assessment. Now, moving on to the nature of assessment. Since a mock exam is used to establish a common meaning, as in to know how much students know about the entire domain of math, There are a lot of implications when we make these exams. First off, we got to focus on both the breadth and the depth. There's no need to test the same subtopic several times. There's no need to test the same simple equation. Let's say sine of x equals a constant 4 different times for 4 different values of a. However, you should make sure that all the questions of the same topic are of various levels of difficulty. By this I mean, you should have an easy question on the sine rule, maybe a medium question on trig equations, a hard question on trig functions, and so on. Or, take another example, probability. You can have an easy question on the probability notation or Venn diagrams. You should have a medium question on, say, normal distribution, and you can also have a hard question on tree diagrams. By the way, tree diagrams can really get tricky. If you're interested, feel free to check out some step questions. The tree diagrams questions are far from trivial. Okay, back to this. A second implication is on sampling. Since we cannot test everything, as we only have short questions like in GCSE, we have to be a bit more selective in what we choose to test, and this usually include big hits. It's also good to keep in mind that every single exam session, aka when you combine all the papers in a single sitting, in the single session. So for A level, 3 papers. For IB, 3 papers as well. For the AAHL course, you should test about 2/3 of all the examinable topics. So, what are the big hits? The big hits are the questions or the topics that will show up pretty much every single year. So, arrow between curves, integration by parts, trig equations. Some topics are tested more extensively than others. So let's say first principles for differentiation. In A level, I've seen it coming up pretty much every single year. In IB, because it's very limited, I have barely seen them on the exam. Moving on to the incline of difficulty. As students work through the paper, the questions should ramp up in difficulty. And this should happen at the question level as well as at the paper level. The reason is that we want to stretch students as much as reasonably possible. Now, I would like to spend a bit of time focusing on the word reasonably. If you give an exam that is too easy and everyone gets 90%, well, the exam doesn't really tell you much, right? Number one, how do you know? No, you cannot really say much about the students who get 100% on that test because they were not given an opportunity to show off what they know if the tests are too easy. If a test only consists of easy questions, you cannot say with any certainty that they will be able to do hard questions. The reverse is true. If you make an exam that's way too hard, you will have a lot of students. You have a lot of students in the lower marks, right? Maybe even getting less than 50%. That doesn't really tell you much about what they are able to do. That tells you a lot about what they are unable to do. And that's the opposite of what we would like to do as exam writers. In fact, that only tells us that they cannot do the hard questions, and they can pick up some art marks here and there for the easy ones. But we don't even know if they are able to answer the easy questions. Also, for longer questions, the first parts of the longer questions should be easier than the last part of the previous one. This is especially true for IB, as the long questions are really long. We are talking a solid 18 to 20 marks at times. So motivation now plays a very important role to keep the students coming back and show off all they know. What makes a question difficult? Okay, so we talked a lot about the incline difficulty. Now, how do we actually know where we are on the curve? Is it an easy question? Is it a hard question? Well, if you're interested, I've written about it in a blog post. So there are three key factors to it, in my opinion. First off is the difficulty of the concept. So let's take two topics, correlation and solving equations using double angle formulae. Correlation, frankly, is a lot more straightforward, especially at the IB/A level level, right? We're not going to get into the intricate working of it. It's just, well, a formula. Or an IB is literally a GDC topic. You enter all the data points, and it's going to spit out the equation of a line. It's going to spit out the Pearson's correlation coefficient. Frankly, there's nothing too demanding about it. Versus solving equations using double angle formulae. Very complicated, because even in the simplest cases, you got to think what identity you are use, especially when there are three of them, like for cos of 2x. And it can get really hard, right? Secondly, apart from the difficulty of concept, the context of application is also very important, as well as the level of scaffolding. So I will talk more about it on this slide. As you can see in the table, we have two axes that I usually use. So we have a level of support. So the extent of queuing or the extent of scaffolding within the question, as well as the novelty of the context of applications. So let's take a look at the first box on the top at the top left. It is a routine simple question. It's very straightforward. Everyone entered for the exam should be able to do with their eyes closed. It's like the first third of an A-level math exam. If students are dropping more than, I don't know, a couple of marks, maybe they should really brush up on the basics. So in this case, I give an example of a very straightforward quadratic equation. That's it. Simple. Might be too simple that it doesn't even make it to the A-level exam. Now, on the top right, we have a question that I consider routine complex. By the way, I borrowed this language from Queensland. So a routine complex question is more complicated than a routine simple one. It's not necessarily hard, it's just longer and usually without scaffolding. So solve the equation, 3e to 2x plus 3e to negative 2x equals 10. This is something you would see on the A-level exam. It's not as straightforward as you have to manipulate the equation a bit, and then you gotta recognize, hey, this is a quadratic in disguise. Therefore, what I can do is that I can use a dummy variable, or I can just factorize. It doesn't have any scaffolding, so students have to come up with all of those steps themselves, and that's a very important distinction between routine complex and routine simple. Now, most exams consist of questions in like on the top row. Routine simple for, depending on the exam, but I would say maybe 30 or sometimes even a lion's share of the exam consists of routine simple questions, as well as some routine complex questions. Now we get to the bottom row, non-routine simple. So non-routine simple, I like to call it a small or a slight spin on the routine questions. And well-prepared students should be able to solve them readily. It is in a complex application, in a complex context, as students probably have not seen this kind of question before. But if they're flexible, aka if they know what they're doing, they might be thinking, okay, so what can I do to this? Expanding this, okay, that can work. Might not be the best idea, but it can work. But how about we use the dummy variable? Et voila. So if we let x squared plus 2 equals t, now you get an equation that's similar to the one in the routine simple box, right? The difference is that students have not seen this before, and you do not give them a cue as to what to do. Lastly, is a non-routine complex question. It's a question in a complex application, in a complex context, in this case, in a complex mathematical context, and also contains low to non-existing scaffolding. So an example is find the value of k so that the equation has only two distinct real roots. Okay, so when students see this question, which probably appears somewhere at the end of the exam, the first thing I do is thinking, okay, what's this question about? Quadratics? Yes. But only two distinct real roots, what does that mean? So might have something to do with discriminants, perhaps. And indeed it is. So after they realized that they would need to use discriminant for this, then they will treat it as a discriminant question and applying an appropriate restriction on the values of k so that this is true. So thanks very much for sticking around. I will continue part 2 where we start talking about how to decide the topics for each question. This is where the fun starts. See ya!